Okay, thank you for joining us for today's webinar, which is happening on both platforms at a similar time on Zoho and LinkedIn Live as well. So, yeah, I welcome you all to this webinar. My name is Akash Pant, and I am the digital marketing team lead at Geo Informatics. Most of the companies and people are new to this webinar today, so we will be little bit telling you about what Geo Informatics do in field of engineering services and sales. So for a overview, Geo Informatics is the leading provider of engineering services and measurement machines like vision measurement machine, blue light scanner, portable arm, quality management software, and many more measurement solutions. So today we are presenting high-end engineering services webinar for manufacturing industries like EMS, automotive, aerospace, medical, solar, OEM, and this webinar is going to be presented by Mr. Sanjeev Gandhi, who is Director of Geoinformatics, and the webinar is divided into two subparts, which include 45 minutes presentation and couple of applications videos in various industries. And in last second part, we are going to take 10-minute Q&A where we will try to answer all your questions. So now I would like to hand over the mic to Mr. Sanjeev Gandhi so he can start with the webinar. All right. Uh,
Very good afternoon. I will take only 1 more minute just to settle this voice and screen share challenge.
Sir, your screen is visible and voice is audible.
Okay, I think now I just want to recheck whether I am audible to most of you.
Yes, sir, you are audible, but you need to share your screen. Which is not visible.
Now I think my slide is also visible to all of you.
No, sir, it is still not visible. Sir, now it is visible.
Wait, because now it is visible, right?
Yeah. Yes, sir.
And it is swapping as well, right?
Yes, 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 yes.
Okay. I think good afternoon once again to everyone there. Uh, my name is Sanjeev Gandhi. I'm heading this company, Geo Informatics. And Geo Informatics, today we are going to take around 1 hour from you. And I can promise you, we are going to add a lot of value in this period. This is a webinar today, especially on engineering services. Most of you know very well, in today's world, people either buy the product or they buy the services. As far as we are concerned, we have both. We can sell you the product, we can sell you the services. Important thing is we need to understand why it is required, why product is required, or why the service is required. So give me 45 minutes of yours, and then of course last 15 minutes I'll be keeping it for discussions, for answering your questions. Well, Geo, from where Geo has come? Geo has come from geometry. When we talk about any object, for example, some of you are from automotive, some of you are from electronics, some of you are from windmill, some of you are from tool and design, some of you are from aerospace industry. All of you are handling some physical object, and this physical object always have geometry. It can be a normal geometry, which we call as a GD&T, or it can be a free form profile, it can be a simple linear dimensions, or it can be a reference dimensions, anything it can be. So geoinformatics from last 22 years is trying to capture geometry in these all parts. For us, it does not matter whether you are from which industry, because end of the day, part is important. Physical part is important for us. So geoinformatics, the name geo has come from geometry, and informatics because this is all IT. End of the day, today we all do these things with the help of technology. Gone are the days when people were using only vernier caliper or micrometer or engineering tape. Of course, these things are very much used today as well. But today, technology is helping all of us. So, geoinformatics helps in converting geometry with IT or with the technology. Where we are located? We are located in most of the bigger cities in our country. We started with Delhi, where is our registered office. We have our tech office, we call as a head office in Ghaziabad. We have another office in Chennai, Bangalore, Pune, and Jamshedpur. We also have some resident offices, but in short, wherever there is an industry, we are present there. Now let us try to talk about today's webinar. Our webinar today has a, I will say, theme: dimensional measurement made simple with geoinformatics. Of course, dimensional measurement is not something new to you at all. You all are using someone or the other for measurement. We only want to say with geoinformatics, you can do everything under one roof. Everything under one roof. My team has given you some takeaways. Of course, I'm showing you the takeaway in the start. We will also show you these takeaways at the end. But when you talk about takeaways, surely we want you to take away certain technology from us, certain case studies from us, certain things like how other countries or how other companies are doing in our country. I will not go into these takeaways right now, but surely I'll be attending this at the end of my presentation. Well, what are the core applications which we'll be discussing today? Everything seems to be very simple, but we will make it, I will say, more simpler by sharing with you some case studies. For example, we are going to talk a lot about today 3D and 2D inspection. We are going to talk about some kind of tool designing. We'll be talking about reverse engineering. We'll be talking about 3D printing a bit. And of course, a lot of things on site inspection services we'll be talking. We'll be talking on testing services. And last but not the least, we'll be surely talking on the calibration services as well. I may not be showing you the slide on each and everything, but I will ensure we attend all these topics today in the best possible way, keeping the time constraint and interest constraint in the mind. I still want to check before I go further. My voice is clear. My slides are getting swapped
Yes.
clear. If someone can confirm.
Yes, sir. It is very much clear. Slides and the voice also.
Okay. Now let us come to the core. When we say technology, can we do these kind of things with the help of conventional method? Answer is not at all. So these technologies come from, unfortunately or fortunately, whatever word you want to use, not from India. This all come from abroad. So when we talk about technology like vision system, we directly go to US. This is a company from US called Microview, almost 75 years old company. When we talk about 3D scanner, we directly go to Germany, very, very old company. When we talk about health scanner, we directly jump to Germany, Wenzel. When we talk about quality inspection system, another US company, Gap and Flush. Do not worry about too many technologies right now. What I want to give a message here is in these two slides. If you see this slide and this slide, whatever engineering services we are doing with the help of these technologies. So we have vision system, we have scanners, we have quality inspection system, we have gap and flush measuring system, we have seal gap measuring system, we have laser trackers, we have portable arm, we have a gear testing system, we have another portable arm for the medium size, we have surface metrology system, we do have shop floor measuring system, and last but not the least, something which we claim, something we are proud of, using all these technology, we are making something in India which we call as a customized machines. So my whole 45 minutes talk is going to be based on these technologies. But of course, I'm not going to bore you with these technologies, presentations, videos, and all. I am going to take you directly to case studies. I'm going to show you directly some of the parts to be measured because our theme today is give you engineering services as a solution. Did we miss in these two slides? We are talking about portable, we are talking about tracker, we are talking about vision system, we are talking about surface metrology, gear testing. Did we miss anything? I will say still it is, see, geoinformatics is a one-stop solution, but still we are not having 100% solutions for every problem. This is a opportunity as well for us. We always aspire to give the solution for everything. But today, in today's scenario, we claim that at least 90 to 95% of your measurement can be done within in-house, within our company. I'm just now putting it down all these equipment by name and by country, which we just spoke. Again, do not too much worry, but keep this message in mind. When you go to, let us say, a specialty hospital, let us say any hospital, I'm just considering the hospital, specialty hospital, there you do not go only for a simple things. There you go for complicated challenges. Same as geoinformatics. Here you do not come for a simple thing. Here you will be coming for complicated things. Here you will be coming for things which are not generally available everywhere. So high precision, vision, video measuring system, for very, very small part measurement, we do it. We do ballooning of the drawings. We do quality management system with the help of high QS software. We do gap and flushness for two-wheeler, for four-wheeler in our country. We do seal and gap measurement system. We do flexible gauging. We do portable. We do blue light scanning, handheld scanning. We do shop floor measurement. We do very large part measurement using laser tracker. When we put very word in a longer way, I mean 100-meter kind of parts. When we say very small part, we are talking about even a stent. When we are talking about a needle. So as you see in our theme also, from tip of the needle to the hair aircraft. So we are capable of doing it. Non-contact profilometry, right? Roughness measurement. like waviness, warpage, surface metrology. We are having a French company with us, gear testing machine from Czech Republic, and so forth. Just to give you one more message, Geo Informatics decided not to go for any organization which are only known for cheaper price. We want to make a niche in our country where we are talking a very high-end technologies. Doesn't matter it is expensive or not, because expensive or not expensive is a perception. If we give you value for money, it doesn't become expensive. And if I give you very cheap thing and doesn't give value, even the cheap thing will be very expensive. So we do not mind saying we are a bit expensive company compared to many organization in our country, but we give you that money back in terms of value. Our customers, plenty of customers, some of you are sitting today in this webinar also, but my message is whether we are talking about automotive, whether we are talking about heavy engineering or defense or energy or aerospace or any other thing or medical industry, we are having solutions for all these industry. Now, talking is easy, but giving solution is not easy. Let us focus now engineering services. When we say services, it can be a simple inspection services of a automotive tank or a two-wheeler brake, or it can be a very complex warship where we have to do class A modeling, or we can have a small welding jig where we have to do alignment of the jig, or circularity measurement, or designing. You want to redesign something within the country, or as I said, inspection of the weld lines. Last but not the least, measuring something 100% before you ship to your customer. So this is a whole cycle, and Geoinformatics have a complete solution. I will be now just moving a bit fast. As I said, whether it is a missile or a gun or a tank or a car or anything, for us dimension matters. Here you see a very high precision turbine, aero turbine. Here you see engine. Engine has hundreds of very precise parts, or the large structure like aircraft. Every physical part has a child parts. You see, these are the child parts. These are the smaller child parts, which are part of this, I will say, assembly. So assembly has one tolerance, child part has a different tolerance. So we do care for that. We measure child parts with a much high precision. We measure assembly with, of course, required precision. This is another small part, and we are trying to measure the dimensions using a scanner. I was showing you before that aircraft and missiles and all that. Now you see, here is a car. Here is a truck chassis. Here is a fixture. This is a Scorpio chassis. Again, machines are same, concepts are same, but the people who do the measurement are different. They are from different companies, different organizations. Here we are talking about again large parts, whether it's a fixture or an antenna, like this kind of antenna, or a big shell, or energy parts, whether it's a turbine blade, or whether it's a JCB bucket holder, or this is a water turbine, or this is a windmill hub. These are all same. Here we are talking about, scanning. As I said, will be surely coming each and everything. I'm just giving you the flavor of the machine which we have, so that you understand when we talk about scanning, we are capturing using a fringe projection technique, complete part, whether it's a gear or a knuckle or I will say again, a turbine. When we talk about, such kind of parts which are used part, because you will not be having all the time new parts. Some parts are going to be used parts. So we are able to measure the used parts and make a drawing out of that. This was a used part from some customer. We made after measurement, we made a CAD, and from the CAD we made the drawing. Another equipment which we call as a roamer arm, meant for larger parts. This is a tactile touch method as a non-contact method. I will be just switching into some videos just to ensure my talking only should not too much, I will say, make you sleep. So let me first show you equipment which we call as a blue light scanner, because scanning is everything in terms of capturing very precise parts. Recheck whether my video is now getting displayed. My video is getting displayed. Someone can reply.
Sir, your screen is visible, but video is not playing.
Video is not playing. Hold on then. How about now?
Yes, sir, it is visible. Can you play it?
Yep. Is it playing now?
Yes. Yes, sir, it is playing.
Okay. This is the physical part which we want to measure for inspection or for, let us say, reverse engineering. So first step is we need to scan this. So what scanning is happening now? This is a scanner. Do not worry how the scanner look like and all, but keep in mind scanner job is to scan the physical object and give you the 3D scan data. It takes couple of minutes depending on the size of the part. Now what you see is nothing but a scan data. This is not a CAD model, this is scan data. Each and every dimension has been captured in this machine now. With this machine now. So let us now show you what else we do when we scan it. I'm going to show you now some real thing. As I told you, I'll be showing you clear data. Once the scanning is done, what we do, I hope now my report is also visible. I'm sorry,
Yes, sir, it
being
is
digital,
visible.
we need to keep checking. Visible?
Yes, it is visible.
Okay. Once scanning is done, let us say this was the scan data. If you see here, this is a scan data, and here is my CAD data. This is my CAD data. With the help of software, we do first alignment. Once alignment is done, immediately you have this kind of output, which we call as a color comparison report. It clearly tells you with respect to this tolerance, what kind of accuracy we have achieved. For example, plus minus 0.0 5 is the tolerance here. So wherever there is a green color, we are showing you that this is within the tolerance. Wherever there is this is a color like red, this is a red color, we are able to give you the tolerance of, let us say, plus minus 2.52 millimeter onwards. And if I just take you down various views, this is one of the view where you are able to capture very clearly what kind of accuracy I'm getting. So you are able to take a decision whether to rework on your tool or whether to accept your tool. If there is a tolerance of in plus minus zero point 0.5 in this case of a light, whether you are accepting it or not, this you are able to take certain decisions. Do not worry, pass, fail. This only tells you that a lot of dimensions will be out of the tolerance. Some dimension will be within tolerance. So like this, you will be checking your part fully. And at the very end, I'm just jumping to the very end, system will tell you this particular thing, which means how many percentage of my part is within plus minus tolerance. How much is like this was a bad 0.6 percentage is my bad part. So it all depends what we want to show. So this is called 3D inspection. And we have 3D inspection. But my job is not only to do 3D inspection, we also want to do 2D inspection, layout inspection. For example, another case I'm showing you how this was a uh, inlet, inlet manifold. Again, scan data, CAD data, you combine together. And here is my 2D inspection report. You see, I am able to check dimensions like the distance between this hole to this reference. This is my reference line. We are able to capture all these dimensions. This is what you do with the help of CMM or portable CMM or anything. So we are able to check the dimensions very, very properly depending on your tolerance with the help of same scan data. Another view of the report. If you see here, what are these? Of course, I am able to calculate the flatness, parallelism with respect to data may, my measured values, my tolerances, etc. So GD&T is very much part and parcel of the measurement. You are not measuring only the linear dimension, you are also measuring GD&T also. How about the cut section? Not physically cutting the part, but cross section, taking the cut section of the data and measuring certain cross sections. Very much part of the system. All other cross sections. All are the, if you see here, some kind of CD we are trying to measure the distance, the distance, but the whole distance. Well, the reason I'm showing you all this, most of you know very well layout inspection. So using a CMM, there you also find the position with respect to data B and C. And again, the product fails here because of tolerance. Here the tolerance is given is by the customer is this one. Again, cross section I'm trying to show, etc., etc. So we will stop here in terms of inspection using scanner. What does scanner do? Scanner can also do reverse engineering. So I am opening this file. I again will check whether I am still visible or not.
Yes, sir, you are visible.
Okay. Now this is a automotive seat. Again, I'm saying whether it's a automotive seat or anything. Just imagine whatever object you are having. We will be able to scan this. This is a scan data. You can see this is not a CAD model. This is a scan data. You can see the people who used to have seen the scan data, they know how to see the scan data. Here is my CAD model of the same scan data. So what we did, we use software like MX and convert scan data into CAD model so that you are able to do reverse engineering for an existing object. Why I'm showing you different views? Because it's a 3D. You are not making 2D. This is a 3D. Everything in today's world, we are talking about 3D domain. If you see here, this is our back where we put our back, and this is of course the seat. And here we see complete CAD model. How you differentiate CAD model? You see surfaces. You see this boundaries, black color lines. So you are able to see the complete surfaces. So what else we can do with the help of scanner? Again, I'm showing you reverse engineering and inspection are the two major activities. I'm showing you now a lot of parts just as a glance through. This was a CAD model of some screw. This is a scan data. What was done? Some kind of inspection or the reverse engineering. This was a CAD model. Using the scan data, we make a CAD model. Fan, you must be wondering why this kind of fan? This is not a ordinary fan. This is a fan for a blower. And some customer want to reduce the weight. There is existing fan, you want to reduce the weight without reducing the efficiency of the fan. What you'll do? You will scan this, make a CAD model, do some calculation, change of thickness, maybe change of material, and try to handle the challenge in hand. Once you have a CAD is very much required for such kind of things. Some bracket, CAD model, scan data, some other part. Just glance through. I'll stop second here. What is this? This is a bone rate, a medical application. Why they want to scan it? Why? Because all of us are having different size of bones, different shape of bones. We need to have certain customized plates. God forbid if you fall down or if you have to put a plates in your, to protect to do certain surgery. What is that? Some kind of object again. I'll be just moving fast. Some light part, some die, many parts. What is that? This is a uh, you know shocker, right? Shocker for the car. And if you see here, this has a child part. Some customers want to scan the whole assembly and give them the child part as a separate one. Absolutely no problem. This is what we do as a part of service. This is a CAD model of the same shocker. I have plenty to show, but time is always a constraint, so we'll follow the time. What is that? Tube. Very narrow, very thin tube with a lot of bends and radius. What do you want to do? You want to either inspect or reverse engineer. Absolutely no problem. Just use a scanner, some forging part, etc. etc. Okay, we will leave this topic here. Now I have a question. Of course, you need not to answer. Let me use this question to move ahead. Whatever you do with the help of scanner, it was meant for, I'll say, medium size part. Whatever part you have seen, it was couple of centimeters. But let us say I have a part which is only 2 millimeter, 5 millimeter, very small part. Do we have that kind of parts? Answer is yes. For example, a stent which goes to the heart. For example, very small tool which you have to measure. What we will do with that? We will be using a different technology. So I'm showing you another video, very quick one. There you are going to see how these small parts are getting measured. I'll be again checking whether my video is getting played again or not.
Yes, sir, it is visible. You can just play it.
Okay. As I said, we have a scanner. Now we are talking about we have high precision vision system from Microview USA. This is a screw, very small screw, and fitted on a rotary chuck. Let's see how we measure it. This is vision system, which is a shadowgraphy based system. And with the help of that, we are able to measure. Of course, this is rotary. Rotary is rotating the part. And here you are seeing the complete check getting measured. Not check, the screw getting measured. By the way, these dimensions are very, very small. And precision required is in sub-microns. In microns, not sub-microns, microns. See this profile. Now Chuck has rotated the part vertical so that we are able to see the top view. Now the bottom view. And finally we get the now important point here. Just touch upon. End of the day, you are not measuring one part and then being happy for that. You have to measure a lot. Sometimes you have to measure the sample. And after measuring the sample, you need to have a complete SPC. How much was the total failure rate? How much was the chi square? How much was the CPK? All these values we are able to give it to you in a very short period as a final output. Another video I'm showing you. Message here is whether you have any part, any physical part, Geo Informatics can give you engineering services to measure that. Same machine, measuring multiple parts. This message is we are not measuring everything with the help of one machine. There are different models are there. When you have a different models, you need to ensure size is important. For example, this machine is meant for very large part, almost 500 millimeter plus onwards. Limitation is 2 meter maximum. This machine is maximum up to 315 millimeter. This machine is up to 315 millimeter. Okay. Once we use such kind of machines, what kind of reports we get? I'll show you what kind of reports we get. This is the report what you get, which you are very used to of handling in a VMM. There will be a actual value, there will be a nominal, upper tolerance, lower tolerance, deviation, and whether the part is okay or not okay. So nominal versus actual, and you get complete measured sketch for the same part. And here you get complete report, and you can see as a manager whether the part is overall okay or not. To me, this part is not okay because most of the dimensions are out of tolerance. Red, 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 you are able to see. So what you have to do? You have to correct your tool. You are not measuring the tool here. You are measuring the part here. So end of the day, part is output of a tool. So you may need to correct this tool. What we'll do now? We spoke about scanner. We spoke about vision system. Now let us say I say to you very small part, medium sized part. Let us say very large part. What is a very large part? Let us try to see that. Is it a large part or not? This one, this is a windmill, 70 meter, 70 meter large. You can see here the part. You see the part? You see the part? This red, I'm putting the my pointer. Very large part. This is a machine called laser tracker. And see the floor is full of, I will not say rust or dust, it's a special compound. And this machine is measuring this large part. So that was the theme. From a very small part to large part, we are able to measure all sort of part. One of our engineers trying to measure very large part. You see that? And machine is different. Before that, I was talking about scanner. Later, I started talking about vision system. Now I'm talking to you about laser tracker. Again, from a company called Leica. It's a Swiss company now taken over by Hexagon. So this is a Hexagon product. And what we are measuring again, nominal versus higher value. Our job is to give you actual values compared to nominal. All the complete values we are able to give you. See the how now you can see how the large part look like. Windmill, the large 70-meter windmill. You can see this engineer of ours trying to measure these PCDs. If you see here, if you see one of the holes, here the flatness is very important, and this PCD is very important. And this gentleman is carrying probe in his hand. I'm not sure whether I'm able to zoom in. Akash, when I use this pointer, is it zooming in or not?
Sir, it is not getting zoom.
Sorry?
Sir, it is not getting zoom. You can just zoom it with control.
Your voice is not coming. Never mind. So we are showing you all these things. Other than we are trying to measure using it CCR. You can see this. These are the large parts what we are talking. What can be other large part? Like, like this. It's another aircraft. It's aircraft scanning, aircraft measurement. This is a scanner, and we are trying to scan the aircraft. This is a scan data for the aircraft. This is what? Antenna. We are trying to scan the whole antenna. This is what? The bridge. When we are measuring a bridge, we are trying to measure that. Some kind of anti-PC we are trying to work, where we are trying to measure a very large part. So message is what? Message is our company is able to measure all sort of such kind of large, small parts. Now I'll be showing you a couple of quick things. Example, here is a bike. Scanner, of course. This is a two-wheeler. Whether it's a two-wheeler or three-wheeler, why people will get it scanned? Because they want to make sure their vehicle is launched with a full dimensional check. And if they have any challenges in a proto vehicle itself, they are able to handle that. So we are able to handle such kind of projects. All such kind of projects are our services. Whatever I'm showing you are real projects without naming the customers, but all of us knows uh, geoinformatics clearly says pick up any bike, pick up any car, pick up any vehicle. Geoinformatics has some stamp over it. Whether it's a very small work or some large work, we have done something or the other. Another small example I'm showing you. Example tank. 650 parts, 80, of course, 82 hours is a wrong thing. It was a reverse engineering of a tank, modeling 2D, all these are the parts we measured, scanned, all these are hours and all that. We are talking about scanning time. How about, now I'm going to show you very quickly my presentation. I'm coming back, which I left in between just to show you. How about measuring a gear? Can you measure a gear with the help of vernier caliper or a general knob instrument? Answer is no. We have to use some kind of technology. We are using using gear tester for that. We are making drawings for that. We make sketch or a very rough art and then make a drawing. We use all such kind of machines. Sometimes we need to cut a part. This part has been cut to capture inside cooling channels. So after cutting, how to align the data? Simple. We use common points before cutting and after cutting, and try to measure such kind of parts. From Toyota vehicle, drive design, some of the tool design, we have the complete tools. I've shown you only already. Toy industry, we work in the toy industry as well. Electronic industry. Gap and flush is also a very important tool. Whether we use a two-wheeler or a four-wheeler, there will be always gap and flush. So we are able to capture these gaps and able to use that. These are some of the pictures I'm showing you for gap and flush. We discussed about microwave already. So in short, geoinformatics provides all such kind of technologies to handle these services. Akash, I want to take some questions
Okay. So,
if
like,
there's any.
yeah, like I have a question from Gyanendra Bhushan sir. So he's asking, is GIC NABL accredited?
Okay. A very important question, because when we claim we are able to measure very precise part for medical, for aerospace, we need to be qualified. We need to be accredited. So geoinformatics right now is ISO 9000 certified, and NABL accreditation is on. Everyone knows NABL is a bit complicated process, takes about 6 months. So we are not yet NABL certified, but NABL's accreditation is on. We have applied for, audits are still to be happening. We are putting the system on. So NABL, by the time I will say July end, we will be NABL certified as well. Till that time, we are using our all artifact, all our gadgets for calibration and for measurement through NABL certified lab only. So that is the answer for NABL calibration and certification.
Okay. So I think this is the answer. So, like, I have another question from Gyanendra Bhushan sir only. Like, what is the make of handheld scanner?
Okay. Uh, Now this is a little bit, I will say, question. Let me answer this way. The birth of handheld system was in China. Of course, Creaform was the first company who started handheld system, but later all the handheld system went into China. But our company, Geoinformatics, recently associated with Wenzel, Germany, and that is what we have started now talking about. This scanner from Wenzel, Germany.
So here is another one question from Venkana sir. So he's asking, can we scan threads and 3D print?
We
He's asking, can we scan threads and 3D print?
okay? You mean threads?
Right, threads.
Not so easy. I think they know thread printing is not so easy. Why? Because 3D printing, unfortunately, cannot give you, I will say, point size of less than 0.1 mm. So, and threads are very precise. So, making that thread in the 3D printing, I will not say impossible, but not so easy. And geoinformatics, I will tell you one project. which had a thread. What we do with how we handle thread challenge? We do not print thread. We do vacuum casting as well. It's a mix of 3D printing and conventional processing to do such kind of challenging things. Threads overall is not very easy with 3D printing.
Okay. I think this is the answer. So, sir, we have another question from Mr. Swapnil. He's asking, can we scan cylinder block, cylinder head?
Under block,
Yes, right, sir. Cylinder block and cylinder head.
very much. In fact, by chance, I had this image, which was a cylinder head only. This one is it visible on your screen?
Yes, sir, it is visible.
This is a cylinder head from I can name now, not a problem. It's a from Mahindra Chennai.
Okay.
If you see here, this is on the left side. Uh, on the left side, you see the complete cylinder head, and then we had cleared after scanning, and we also made it from this side, and we made a complete CAD model. So Geoinformatics does cylinder head, cylinder block, even the dice for that. So even the cores, sand cores, complete engineering activity of the cylinder heads we are able to handle in-house. As I said, cylinder head, cylinder block, uh, um, cores, sand cores, all these we are able to measure using 3D scanner. 3D scanner is the right technology for cylinder heads.
Okay. Okay, so I think they got the answer. Uh, yes. So Apnil sir got the answer. So sir, we can continue because we don't have any more question for now.
Okay. Okay. Now I want to just show you one more video to give you one message. Give me a second. What is that message? Message is slowly, technology is going into inline inspection. Whatever we spoke today is standard room inspection. But standard room inspection is getting converted into inline inspection. So let us try to see this video. My video has come up now on your screen.
Yes, sir, it is coming up. You can play it.
What they do now? They want to measure the part in the line. They don't have time. See, no one has time to do post-mortem, which means you produce a part, bring the part to standard room, and then start measuring. They want to measure, they means our customers. They want to measure all the part in the manufacturing line itself. So Geoinformatics has established one more department we call as a smart department. Smart department, of course, are having smart people, but more than smart people, it has smart technologies like sensors, robots, AI-based solutions, machine learning. All these we are trying to do. Let us try to see this. This is the measuring in the line. Of course, this is just an example we are showing. Here you see now the data, and these are parameters. Let me show you the parameters. Here are the parameters. What is the gap? What is the filling? Total we are able to see. Let me show you quickly one more example. These are the sensors. Just keep the parts. A lot of features are there. This is a sensor.
Some features. Everything you need.
This is a sensor.
Formed. and web browser. So in this screen, we see this up where the 3D model is acquired.
And then you get complete radius diameter in the line itself.
Data missing, yet there's sufficient data to complete the measurement.
One more thing I would like to show, uh, just to give a message that geoinformatics is very much in now automation as well. But automation services is not possible. Automation means we can automate your measurement processes. This is what the message is. You know, whatever you have, whether this is from A competition or B competition or A brand or B brand, we will be able to automate your complete processes. Example, this is a real life case without naming a customer. They are producing in hundreds, and this nozzle is very important. I'll just mark that. This is a part which will pass through on the conveyor. Stop for a second, and immediately this indicator red and yellow, red and green will tell you whether to keep the part on the line or take away. Because this part, this red color thing, this part shouldn't go to the assembly line now. If you stop for a second, green, yeah, green, go next, like this. This is what people are looking now. We call as the automation of your measuring domains. I will also show you a couple of more things. Example, till the time I have couple of more minutes. Just to give you an example, some customer come to us, they will give you a product, for example, and they want us to check the symmetry. See, when we say consulting, you know, geoinformatics word for consulting private limited. What is consulting? Consulting means is we can give you engineering services where we can tell you whether this product is okay or not okay. Not eventually only, but other way also. Like symmetry check. Here is this bike we are trying to check before launch of a new bike whether this is symmetric or not. Symmetric means my left handle and the right handle should have a same height from the ground, isn't it? My left indicator, right indicator should have
Your
a
voice,
same.
hello sir, your voice is breaking.
Sorry, my voice is breaking. Still it's breaking. Is it okay now? Akash, is it okay now?
Yes sir, it is okay now.
Okay. So now it's okay. Now in this, we are checking the complete symmetry of the object. So customer is not asking for a dimensional report. They are asking us, here is a problem. We are launching a product. We want to check whether it is symmetric or not. Okay. So I want to conclude by, as I said, I will show you what are the takeaways. I hope we could takeaways or not. First takeaway was how geoinformatics can help your organization to achieve precise and accurate measurement. I told you geoinformatics has all sort of equipment, CMM, VMM, scanners, gear-based testing, surface metrology, and laser scanner and handle scanner and all that. So come to us, we will be able to give you solution irrespective of accuracy and size. Takeaway number 2 was engineering services, whether it's a 3D, 2D, reverse engineering, tool or mold design, testing services, calibration services, prototyping, laser tracker rental. Yes, I did not spoke too much on rapid prototyping or 3D prototyping because 3D prototyping, I will say we have a limited services. We do not have everything. but rest everything we have. Takeaway number 3, how geoinformatics measurement technology can help you to achieve 2 micron accuracy to 100 micron per meter. We are able to use 2 micro using vision system. If you remember, we showed you micro view and 100 micron per meter and all. We showed you the very large aircraft as well as the windmill. Takeaway number 4 was quality assurance of QA regarding how geoinformatics high-end dimensional measurement services can help industries of various domains, whether it is automotive, aerospace, medical, OEM. Again, I'm repeating, both of you in today's webinar are from different industry. I can see automotive, I can see EMS, electronics, I can see medical, aerospace. So it does not matter to geoinformatics what is the part. What matter is what is the size of the part and what is the tolerance of the part and what you are looking. Only these 3 things are required. Rest is all ours. Rest all we are able to handle. We could speak a little bit about the 3D and 2D inspection, reverse engineering, science section, uh, 320 little bit consulting services and calibration services, etc. We could speak. So Akash, um, it is 4 o'clock, exactly 1 hour.
Yes, sir.
If you
So
want to continue,
we have 2, 3 more questions, and
I can
meanwhile,
answer.
everyone can post their question in Q&A section, so we can answer it. So we have one question from Ms. Kulkarni. She is asking, Geo sell product or is it a lab? If giving engineering services, how you give services out station?
I missed the first half of the question. Can you repeat?
Yes. Yes. So Ms. Kulkarni is asking, Geo sell products or is it a lab? If giving measuring services, how you give services out station? They are asking for
Okay,
out station services.
okay. Well, sir, I always compare geoinformatics as a lab like pathology lab. Pathology lab is where you go for any testing. For example, Dr. Lal or any lab. We have a lab in Pune, we have a lab in Ghaziabad, we have a lab in Bangalore. These are the 3 places where you can walk in. And even when you have a small size part, we can bring our machine as well. So it all depends. So, Kulkarni ma'am, answer to your question is you can walk into our office. We have a 3 major labs, or we can come to your factory or your office for the measurement, but depending on the part size. So answer is we have both concept of in lab and at office or at say customer place.
Also, she is asking like Geo sell products also.
Yeah, we sell the product also very much. I will just show you this. Since today theme given to us was talking about the services, but slide is visible. This is a slide which I want to show.
Yes,
This
sir,
slide
it
is
is
visible to
visible.
all of you.
Yes, sir, it
We
is
sell
visible.
these products because these are all our partners. We do sell the products also. Our company is a sale and service company. So if someone want to buy portable CMM, someone want to buy vision system, or someone want to buy handheld scanner, or someone want to buy a vision system, photogrammetry system, or gear testing system, we can sell that as well. In fact, we are known as a company having application driven sales. Since we do ourselves like you services, we ma'am is you can surely buy products as well as services. Ash,
Sir, you are not audible.
now I'm audible.
Yes, sir, you are audible now.
The last message was not coming. The I just said sale of the equipment. Was I
Sir, you
audible?
can repeat it. You can repeat it.
Okay. As I said, as my screen also shows, if it is still visible, we
Yes, it
sell
is visible.
we sell these machines. We surely sell vision systems, scanners, everything mentioned on this slide from top to bottom. we are selling these machines as well because, as I said, these are our partners. We sell machines for microview, we sell third dimension gap and flush. From Hexagon, we sell scanner, we sell sensors for inline measurement from BLI, we sell ballooning software and QMS software from High QA. All our partners. So we do sell.
Okay, so I have one more question. It is from Mr. Akshay. He is asking, we have Vertex 311 SCVMA machine, but joystick getting sticky noise after 10-11 months. We have replaced it 2 times. What to do?
Okay. Um, joystick is like a toy. Like without naming a company, I will tell you one of the engineer were using joystick very roughly. Like you are using PS2 or PS3, but joystick you should be using it very carefully. So if the joystick has gone bad and if it is under warranty, surely it is going to be replaced. Otherwise, generally joystick doesn't go bad. Only there is a pendant. There is a pendant, circular kind of thing, which moves the X, Y, or Z direction. That can be changed. So if they can give us the company name, we can quickly ask our existing customer management department, ECM people, Rishabh. They will take care.
Okay,
Akash,
that's
take the sir's name and number so that we are able
yes,
to support them quickly.
yes, sir, definitely. So these are all the questions. So we can just wait for like 4 or 5 minutes for more couple of questions. If anyone have any question, they can just put down in Q&A box. So we are waiting for that only.
Absolutely.
Meanwhile,
We are
meanwhile,
tell me.
sir, you want to present or say something, you can do that.
Okay. I just want to show you one. Just give me a second. Just give me a second. I need to. Where was the video?
And go on the top. Side.
यहाँ पे? ये भी है। Oh, yeah, yeah. Sorry for that. I just want to now share again screen. Is my screen visible again?
Yes, sir, your screen is visible now.
Okay. Geo Informatics website I have just opened. Anyone can go into this website. Here we are showing services, solutions. Solution is very important. Let us say someone want to go into automotive. You go to automotive. And here we have given a lot of solutions in automotive. What we do, for example, solution for child parts, roulette scanners, portable CMMs, only for automotive, cameras for by Cognix, 3D sensors, all automotive, for chassis measurement, handheld scanners, laser tracker, CMF for automotive, portable CMF for automotive. Getting my point, Akash? If
Yes,
our
sir.
team can, if anyone want to know more about geoinformatics, just go to gicpl.com and here go to solutions and you have a lot of solutions from us.
Right, even I
I want
have dropped down the website link into the chat box so everyone can visit the link and just go to the solution and check out.
I just want to play a one video which is the old one. Of course, this is not the new one right now, but still we can, look into that. I just want to just move much further.
Hi, this is Pawan. I'm working in Geo Informatics from last 8 years. Started as a technical job on a very basic level. Today, I'm very happy working as a high in the work.
Anyone can see this video both on YouTube as well as on website. This explains our services also very detailed way. Akash,
I
any
think, sir, we
question?
don't have any more questions. So I think this is it for the day. So,
Okay.
so, so,
Let
sir,
me
you
show my face as well. So thank you so much to everyone there. I know spending time on webinars nowadays is not so easy. The reason, you keep getting a lot of invites for the webinars, a lot of internal meetings, a lot of other things. But geoinformatics do believe giving half an hour, 1 hour or such kind of things help in building up confidence on the technologies. Within our country, things are changing a lot, and in metrology domain, in CAD CAM domain, or in domain of high precision measurement, I believe geoinformatics is going in a right direction. But of course, with the support of customers, feedback from customers is always important. So I will say thanks to everyone there who has given time today. And if you have any question, feel free to visit us. Feel free to talk to us. Akash is my team member who is in touch with you on day-to-day basis. So once again, thank you so much. I'm looking forward to work together.
sir, thank you so much. So I think this is the end. And thank you, everyone. We appreciate you being here. Don't forget, we are always open for free one-on-one demos for your organization to understand and solve all your manufacturing needs. Thanks again for joining us today, and we will see you next time with another metrology webinar. Thank you, everyone.